All right, so remember when I said if you're given a range or a domain value like this, so just find the absolute extreme values on the function of the function on this interval. So this one's a little bit different. So you can still find critical values, but you got to test the endpoints. So these are a little easier when we first started, if you remember. So we'll approach it the same way, but then we'll test 27 and 8, okay, or negative 27. So let me write that down here. Okay. So exam 3, review. All right, find number 1. Find the absolute extreme of values of the function on the interval. So they give me f equal to 5x to the 4/3. And the interval they give me is negative 27 until all the way up until 8. So they wrote it differently, but this is the same thing, right? So find the first derivative. This will be a simple power rule. Bring down the 4/3. 4/3 minus 1, that's going to be 1/3. So this will be 20/3 x to the 1/3. So set this to 0. So that will give us 20/3 x to the 1/3 equal to 0. So that only happens when x is 0, right? You guys see that? Or I didn't show any work, but see if I plug in a 0 there, right? That's the only way this will be 0. Okay, so we have to test negative 28, it's 27, and number 8, and the 0. So for these type, when they're restricted like this, all you have to do is plug in the critical numbers and the endpoints. Then see what is the smallest and biggest y value. Okay, so basically plug in f of negative 28, see how big that is, or how small that is. So that would be 5 times negative 28 to the 4/3 and then do f of 0, which will be 5 times 0 to the 4/3, which is 0. That one's easy. F of 8 will be 5 times 8 to the 4/3, which is right. Cube root of 8 is 2. 2 to the 4th is 16. 5 times 16 is what's left over, which is what is that? What's 5 times 16? Is that 80? I think it's 80.
Yeah, I got negative 27 too.
For this guy, really? Or f of 8?
For the first one.
Oh, for the first one.
Yeah.
Yeah, it was like 5 times 4/3, and then it becomes like what was it?
Yeah, that sounds right. Let me double check it out.
Oh, I thought you got it from the 27 from up above. Like, isn't that the X value?
27. Yeah, I put 28 for some reason. Should be 405. What you guys got? Okay, so the absolute minimum is going to be 0, 0. Absolute maximum is going to be negative 27, 405. So you just test these three here. That makes sense for this first one.
Yeah. So when you set it equal to 0, I thought you were solving for the x, and you're saying that the only reason why x equals 0 is because that's the only thing that would make it 0.
Oh, one more time, sorry. This one?
Sorry. No. So all the way on top were the first derivatives. Yeah. When you set it equal to 0, you're saying 0 is the only thing that'll make that equal to 0.
Yeah, exactly. Like, there's nothing you can plug in here that'll make it 0 other than 0. Think of it this way: 20/3 times a number is 0. Well, that number needs to be 0.
Oh, okay. For some reason, I thought I saw an addition or subtraction sign. I was like, wait, but yeah, no, never mind. All right, sorry.
Oh, you're good, as long as it makes sense. So number 2 will be the same thing. You'll take a derivative, set it to 0, and check the critical numbers and the endpoints they give you. That's what we do. We check the endpoints right here. Should be 27. And the 8. And then we tested the critical number and said, okay, what's the biggest and what's the smallest? Those are my answers. Yeah. Any questions? Number 1. Let's move on to 3, I guess. Determine all critical points for the function. So we're going to have to do the quotient rule, right? No way around it. So derivative will be the bottom times the top minus the top times the bottom derivative over the bottom squared. Minus root of this will be just the 1. So this will be multiply the -6 over -6 minus 12 plus 6x. Those are gone. So find all critical numbers. It has any because we can't set that to 0. That's weird. Let's see. Let's look at the answer here. Yeah, there is no critical point. Check it out. Because when we took the derivative, there was no way you could set that to 0. There is no solution to f prime of x equal to 0. Therefore, there are no critical points. Any questions on number 3? Okay. Find the extreme values of the function. And where they occur. So take a derivative. Double check the formula. Yeah. It's the bottom times the top derivative minus the bottom derivative times the top. Derivative of this is a 9. There it is. Derivative of this will be 2x times 9x. I forgot to put the denominator. Is that okay? Okay, so multiply this out, that'll be 9x squared plus 9 minus 18x squared. So that'll be negative 9x squared plus 9. All right, that factor now is not gonna help. Okay. So set this equal to 0. That will give us negative 9x squared plus 9 over x squared plus 1 squared equal to 0. Right? So the only way this will be 0 is when the numerator is equal to 0. So solve for x. So yeah, two critical numbers. Now plug these into the original to find the location. So y is equal to, so for x equals 1, okay, so there's my two answers. Now let's look at the question again. What did they want?
They want the extreme values of the function and where they occur.
Yeah, so
So they,
negative 1, negative 9/2, so we got right. And 1 9/2, yeah. So if you write them as a point, this would be 1 9/2. This would be negative 1 -9/2. Any questions on number 4? I'm not going to ask about number 5, so I'm going to move on to 6. Let me know if you're cool. If you need to see that page. If not, I'll start the next one. So using the derivative of x given below, determine the intervals on which f of x is increasing / decreasing. So they went ahead and gave us the derivative. That's nice of them. So all you have to do is set it to 0. The derivative equal to 0 would give us x to the 1/3 times x minus 6 equal to 0, which means that x to the 1/3 is equal to 0, or x minus 6 is equal to 0, which means x has to be 0 or 6, right? So those are our critical numbers, basically. So we
I
gotta
don't,
find-
s-
What's up?
sorry. Oh, I don't see your page. I don't know if it's my
Shit.
screen is just frozen.
Yeah, we can't see
My
it
bad.
either. It's like
So I took what they gave us, right? The derivative, set it to 0 here. And then you just, once you have that, you just set each, since it's factored, right? You set the first factor to 0 and the second factor to 0. So x is 0 and x is 6. So those are the critical numbers, and we're just going to test around. So pick whatever you want, right? I'm going to pick 1, 8, and -1. Okay, 1 second. So here we go. Derivative of -1, or at -1, will be -1 to the 1/3 times x times -1 minus 6. Then we're going to do 1. That'll be 1 to the 1/3 times 1 minus 6 f derivative at 8. Okay. So this will be -1 times -7, right? Which is 7. This will be 1 times -5, which is -5. This will be 2 times 2. So over here, I am positive. Over here, we're negative. Over here, we're positive. Right? So we're increasing from -infinity until 0 and union with 6 till infinity. Decreasing from 0 to 6. Any questions on number 6? Yeah, that's what they got. Oops. Okay. Okay, number 7. Determine the open intervals on which the graph is concave downward. Weird. Well, the answer one of them. Okay. So for this one, you're going to have to do 2 derivatives. Now we could technically rewrite this, right? Because I don't like the quotient rule. Maybe you guys do. I don't. Do you agree that this is the same as 28 times x squared plus 8 to the -1? So then if I do a derivative, do you agree that this would just be -28 x squared plus 8 to the -2 and then times the derivative of the inside? Right? That makes sense.
Yes, sir.
So doing a second derivative would require a product rule here instead of a quotient, because I changed it. But let me go ahead and write that a little prettier before I do it. So 2 times 28. That would be what, 56, right? You don't have to do the derivative this way if you don't want to. I just chose to do it for no reason. So second derivative will be derivative of the first times the second plus the first times the derivative of the second part. Right? So this will be negative 56 over x squared plus 8 squared minus 50 minus plus negative 56 x times derivative of this will be negative 3 times x squared plus, sorry, negative 2 plus x squared times x squared plus 8 to the negative 3 times 2x. Right, that doesn't look pretty at all, but here we go. So multiply all these numbers. Negative 2 times negative 56 is positive, right? 112 times another 2. That would be positive 224. X times x will be x squared over x squared plus 8 to the negative 3. Oops, sorry, positive. Okay. Anyway, they said, when is this concave up or down? So we need the critical numbers. Unless we can show that this will always be negative, then it'll be concave downward everywhere. But currently, because I use a product rule, it's not one fraction. You see that? So the derivative is easy, but now I have to combine these fractions. So maybe it wasn't worth it. I don't know. We'll see. So multiply the top and bottom by x squared plus 8 to get the same denominator. So now they're the same, so I'm going to multiply or add these together. So I'll get to here. Multiply this nonsense out. Does not look like it'll always be. So negative 56x squared plus 224x squared minus 448. So 224 minus 56. That'll be 168 x squared minus 448.
I don't think that's right, sir.
Where? Where are you? seeing a
The
mistake?
448. I actually have been practicing these a lot because I wasn't good on them on the last test, and I've been using this app that helps me check it, and that's not what I got.
Well, let's see. Maybe I made a mistake along the way.
Yeah, for sure.
Was the first derivative fine?
Let me see. Yeah, so the first derivative, I got negative 56x over x squared plus 3 to square.
Okay. Derivative that is here.
Is the denominator? Oh, maybe that's why, because the denominator's 8. Ours is 3. Okay. Okay. I think that's what the difference is.
Did you find a mistake or?
Oh no, because I'm looking at the denominator and I'm on the review, I saw 3, but in the denominator you have 8, so maybe that's the difference.
Oh, right. It should be a 3, but I don't think it will make a difference.
Oh, okay, yeah, then you're good, then you're fine. That's probably the only reason why it's different.
Yeah, go ahead and change them all to 3s. I don't know why I got put an 8 there.
It's okay. I've done the same thing. Like I've had to like be really meticulous about my
Mhm.
steps, because sometimes I'll overlook one little thing and it changes the whole derivative.
Oh, man. A lot of 8s. I think it's gonna matter right here. This part needs to be erased. Okay. It'll be negative 56 times 3.
Yeah, that looks better.
Okay. So 224 minus 56. That'll be 168x squared minus 168. Means I can factor that now. Here's the second derivative. Is that what you got? Yeah, we did the Ethan. We did the chain rule here. Yeah. When we did this derivative,
Yeah, I saw that. For the yeah, you product for the second part, but that just had confused me because it looked like that would be used as a chain rule, 'cause there's an outside function and inside function, that negative x to the x squared plus 3 to -2. Like in my head, it would have been chain rule. You use product rule, but just like I was confused why.
well, we're doing a product rule on this whole thing.
Mhm.
But during that product rule, we had a chain rule here.
So we product ruled it, and then at the end we chain ruled it.
Yeah, technically we're doing a product rule, but within the product, there is a chain rule to do here. And that's what I did here. So you bring down the -2 times the derivative of the inside, which is 2x.
Oh, okay. I see.
And that's just there.
Okay, thank you.
Okay. So we found the first and second derivative. They're not pretty, but oh well. Determine the open intervals on which the graph is concave down. Okay. So right here at the end, we have a possible 0, right? So these, when we set the second derivative equal to 0, we're going to get only time this will be 0 is when this part is 0. So x is 1 and negative 1. So the question is, where are we concave up and down? I think it'll help to graph it just so we can see. So our original function is 28 over x squared plus 3. So there's a critical number, but it looks like we're concave down from here to here, right? This section. But after that, we go concave up. So what we can do is check around those 2 points, 2 inflection points, right? We found the second derivative equal to 0 at 1 and -1. You see how concave down, and right after that, we're concave up. So -infinity to -1, concave up. 1 to 7, concave up. In the middle, -1 to 1 is concave down. So visually, we can answer the question right away. Right? -1 to 1. But using derivatives, what we would have to do is just test around the kind of like create second derivative test similar to the first derivative test. So if I plug in a number here, which is 0, number over here, which is 2, -2, into the second derivative. That'll be -2 squared minus 1 over x squared plus 3. So -2 squared plus 3 cubed. So this will be positive on top and positive on bottom, so plus. Yeah. 2 will be the same because you're going to square those numbers, right? This will also be plus. If you plug the numbers into your calculator, you'll get a positive number. But you plug in a 0, you're going to get 168, 0 minus 1 over 0 plus 3 cubed, which will be -168 over 27. So negative. I didn't do these two just because it was going to be annoying, but if I did the 0, is that okay? You see what I'm doing? That makes sense?
Yeah, you're plugging it in so you can see where it increases or decreases, so you can get your intervals.
Yeah, pretty much. But since we're using the second derivative, we're checking concavity. So concave down from -1 to 1. Concave up from -infinity to -1 and 1 to infinity. So very similar to increasing and decreasing. But since we're using the second derivative, we will find out about a concavity instead of increasing. But the only answer for this. Right, and you guys cool on this one? All right, the next one. It says find the point of inflection. So we need to find two derivatives, set it to 0, and find out where it's an inflection point. Okay. Number 8. Find the point of inflection of the graph of the function okay, so here's f. Let me switch back. Here's number 8. F is sine x from 0 to 2 pi. Derivative of sine is cosine. Second derivative is negative sine. So when is the negative sine equal to 0? On the unit circle, this only happens at 0 and pi. So the answer is just this. They wrote pi as pi, 0. Any questions on number 8? Very good.
Sure, just out of curiosity, can you explain to me why it's just pi?
Yeah, sure. But it's
I know we
0
have to put the zero.
0 and
Yeah.
pi.
Right, yeah, I know how we got the 0. I just want to understand why it's just pi, because I don't know. Like, the questions like these are ones I don't know, so I want to make sure I understand.
Okay. Well, it's all up to the
Oh, wait, did we get pi?
Circle.
Because that's what it is on the unit circle.
yeah.
Oh, okay, then never mind. Okay, I got it.
Oh, okay.
Yeah, I'm getting better at it, but I just have to keep remembering that that's what the reference is.
Mhm. Yeah, the only time sine is 0 is at those angles.
Right, okay, cool.
So what's the point?
What's up?
The point of the inflection?
The point, the x values are going to be 0 and pi. So if you want the
So we
actual
still have to
location,
find our test point.
points of inflection are 0 comma something and pi comma something. If I plug it into the original, I would get 0 and 0. But these are the x values that do that. So if you give me the x values or the points, either way, it's fine.
Do you get 0 as the y value? Because when you plug pi into the second derivative, it just equals 0.
No, you plug them to the original to find location.
Oh, okay.
But pretty much, yeah, it's the same thing, right? Sine of pi is 0. Yeah. All right, so final number without using L'Hopital. So the limit as x approaches infinity, 3x plus 6 over 7x squared plus 7x minus 7. So the degree in the bottom is bigger, so we should know it's going to go to 0. Right? The way we can show our work is to divide every term by the highest power. So that will give us right, this reduces to 3 over x. This reduces to, oh, let's just say the same. This reduces to 7. This reduces to 7 over x minus 7 over x squared. So all of these go to 0, leaving me with 0 over 7, which is 0. That was the technique we did back in beginning of chapter, sometime in chapter 2, I think. Any questions on number 9?
Why do all the x values turn to 0?
Because the x is going to infinity, so this becomes an infinitely small fraction. Small.
Oh, okay.
So they all go to 0. The only one that's left is that 7. The 0 over 7 is 0. So now let's do 11 because 10 looks like it'll take too long. And we did one of those recently, or similar to that one. Let's see here. So a rectangular sheet. Perimeter 27 is rolled into the cylinder. What values of x and y give the largest volume? Okay, so we need the volume of the cylinder. We may need area, a rectangle, but for sure we need perimeter. Okay, so we write down the perimeter formula. Perimeter is equal to 2w plus 2l. You guys remember the volume of a cylinder? Let's look it up. length of the cylinder is equal to pi r squared times height. Okay. Excuse me, we sleeping today. All right, so pi r squared. Yeah. Only difference is they're calling the circumference equal to x. What is the circumference formula? Circumference is 2 pi r. All right. So maximize volume. So for sure, we want to take a derivative of v. But and they're using x and y, so let me change these to what we say length was the longest one, right? So we changed volume in terms of y. It should be, I mean, if we change the height, it should be just a y here, right? But what is the radius in terms of the rectangle? If you look at this, I'm rolling this piece of sheet up into a cylinder. So they're saying that x is equal to the circumference. So x is equal to 2 pi r, right? So is that what you guys are understanding? So that means that r can be solved for. This is circumference equals to x. So r is equal to x over 2 pi, right? So now I can get this in terms of x's and y's. Okay. Does this make sense so far? What we're doing? Okay. So I'm gonna use perimeter to get this in terms of one variable. So they told us the perimeter was 27 centimeters. So that means that if I solve for y, that would be 27 minus 2x equal to 2y divided by 2, that'd be 27 minus 2x over 2 equal to y. That means that volume is equal to pi times x over 2 pi squared times 27 minus 2x over 2. So I got volume in terms of one variable by using the perimeter that was given and the circumference formula. Does that make sense? So that's when you do the derivative with respect to x. Go ahead and multiply this out, I guess. That will be x squared over 4 pi squared times 27 minus 2x over 2. So this is going to be a product rule, right? One of these pi's will cancel, so that's cool. So derivative of the first one will be 2x over 4 pi times the second plus the first one times the derivative of the second, which will be negative 2 over 2, which will cancel, right? This will cancel with that 2. These will cancel. So I'm left with x over 4 pi times 27 minus 2x plus negative 1, right? So multiply all this out, that'll be 27x minus 2x squared over 4 pi minus x squared over 4 pi. Combine them, we will get 27x minus 3x squared over 4 pi. So there is my derivative. Make it a little prettier. Factor 3x, that'll be 9 minus x squared. Right? Any steps that don't make sense?
When you took the derivative of the x's, how come you didn't use the what is it, the quotient rule on both of them?
Well, this is just a number. These are just numbers.
Oh, okay.
It's like having an x squared over 2. You know what I mean?
Okay, yeah, no, that makes sense.
So we're trying to maximize volume. So we gotta set it to 0, right? So x equals 0 will be the first part. 9 minus x squared equal to 0 means that there's a, skip the algebra. X is equal to plus or minus 3. So x can't be 0 because it needs to be, it's a dimension, right? X cannot be negative, so that doesn't make sense either. So the only solution is x equals 3, it looks like. Oh, shoot. Mistake right here. I factored X, right? This should be 1. My bad. Good thing I was stick towards the end. X is 9. So this is the only one. So you set this to 0 and set that to 0, and you solve for both. Let's skip that minor step. Is that okay? Do you guys see where this came from? All right. So this is the best X value that maximizes volume. So now plug this into an equation that has Y. Be this one. Don't matter. So if X is 9 and Y is equal to that means that Y is 27 minus 2 times 9 over 2, which is 27 minus 18 over 2, which is 9 over 2. So our answer will be X equals 9, Y equals 9 halves.
I'm sorry, what made you use 9 instead of the plus or minus 3?
Well, that was a mistake. There was no plus or minus 3. Let me show you the work. So this is the work that we skipped here. Right, so you see, the only way this will be 0 is if the top is 0. So set this to 0. Set this to 0.
Oh, okay.
But there is no square. So the answer is X equals 0 or X equals 9. So you choose this one because it needs, it's a dimension. That makes sense?
Yes, it does.
So once you have X, you just plug it in to get Y. Here. You can use the perimeter equation or whatever you want, as long as it has X and Y. So excuse me. So that's what they got here. Nine and 9 halves. Number 12 is Newton's method. It was that formula, you guys remember? Okay, so it says apply Newton's method. Apply the Newton's method to find out the intersection, which means you have to set them equal to each other, or in other words, subtract them. So to keep it simple, apply Newton's method to h of x equal to 2x plus 2 minus square root x plus 6. First derivative will be 2 minus 1/2.
I don't know if you switched your screen, but it's not switched.
Oh, shoot. Dang it. I forgot again. All right, so to apply Newton's method, you just take those two and subtract them, right? And then do the derivative. Derivative of this guy is just a 2. Derivative of this will have 1/2 and then negative. So now we need the formula for Newton's method. Let me go look it up real quick. Oh, here it is. Newton's method is xn plus 1 equal to xn minus the function at xn over the derivative at xn. Okay. It does not say where, oh, it does. It doesn't tell us where to start. So I'm going to choose 0, I guess. See if that works. Okay. So if I want to find x1, so let x0 be 0. x1 will be 0 minus f of 0 over the derivative at 0. So this will be 0 minus two minus root 6 over you probably use a calculator here. Nine five over. This is when it differs from 1,000. Okay. The derivative will be 2 minus 0.5 square root, or 0.5 times parentheses of 0 plus 6 to the negative 0.5. Okay, so that'll be 1.796. So if I divide these in my calculator, should be about 0.250. Okay. Now looks like that's what they got. So if you were to do it again, x2, that would be 0.25 minus f at that value divided by the derivative at that value. And you're going to see that it doesn't change much. So this will be the answer. Okay, so that will be 0.25 minus 2 times 0.25 plus 2 minus second square root 0.25 plus 6. Down here, we'll put 2 minus 0.5 times 0.25 plus 6 to the negative 0.5. Yeah, see how it doesn't change much? When you do it again, it's the same thing. So that's our answer. Yeah, it's just a formula, right? So do the formula twice until you notice it doesn't change much. Don't worry about the last few questions, the differential and the linear approximation, just up until 12. I guess we'll stop here because we don't have time for another one. You guys have any questions in general?
I have a question. I have a question about number 2, just because on that one I wasn't sure how to like distinguish the answer.
Number 2.
If you're looking for it, we didn't do it.
Oh, 2. Yeah. Yeah. What's your question?
So on number 2, so I kind of got it down all the way until like it was what's it called? 'Cause it's asking us to find the absolute extreme values, but up until the point where I know I have for sure my maximum. I just wasn't sure how I distinguish like my minimum, like the part where it's like half. I have 0, but I'm not understanding how to make sure like what the half value is.
Well, you just plug in. We plug in this number into the derivative. I'm sorry, into the original function. Plug that number in there, but also plug in the critical numbers, which looks like it's going to be pi. Yeah. Okay. So when you plug in 1, 2, 3 values, right, you're going to see which is the biggest one and which is the smallest one. Then you choose max and minimum for the biggest and smallest. So you need to find pi by taking the derivative of this guy and setting it to 0. Like we did here up top on the last one. Over here we did a derivative, set it to 0, and we found x equal to 0 was the minimum, and negative 27 that we tested with max. that make sense?
Yeah, a little bit.
Like right here is what we did. Number one. Take the derivative, set it to 0. Here's the derivative. X equals to 0 is a critical number. So you plug in this number and these two. And we found when we did those three, the 0, the -27, and the 8, that the smallest one was 0 for this example. The biggest was at -27. So we found out these two were the maximum and minimum. So you got to
Yes.
find that critical number.
So the two numbers they gave us were just 0 and like 7 pi over 4.
Yeah, so you got to test those and then compare it to the critical number.
Okay.
So there should be at least 3 values for that one.
And when you plug in the values, you plug it into the original equation, not the first derivative after you get it right.
Right, because the first tells you about increasing and decreasing. The original tells you how big it is.
Right. And then the first derivative is the critical number, right?
Yeah, first derivative equal to 0 gives you the critical.
Okay.
All right, guys. We'll see you guys on Monday. And if you want to come office hours, feel free to.
Have a good night, sir.
Have a good night.